This tutorial will show how to create a composite floor framing system utilizing rectangular and cylindrical grids. We will start with the grids already defined. So that we have more room to work, shut down the 3D view. Next, we will draw the primary framing using the Create Lines in Region command. Note the properties selected and draw a selection box around the entire plan. Next, draw the columns at all the grid intersections by using the Create Columns in Region command. Next, create the composite secondary beams. Switch the number of beams to 3 and set them parallel to X. For the composite beams in the cylindrical region, set the number of beams to 2 and set them parallel to R. Note that the columns drawn were oriented in the direction of the major model axes. However, we could change the orientation in the cylindrical grid by selecting the column and clicking Assign, Frame Line, Local Axes, and selecting either column major direction is radial or tangential. If we select radial, the column is redrawn. However, for this model, we will leave the columns as originally drawn. Now we add the floor deck with the Create Areas at Click command. We need to change the orientation of the deck to span across the beams, so select the 4 rectangular areas and 1 supporting beam and click on the Assign, Shell Area, Local Axes command, and then click on the Normal to Selected Beam option. Note that the deck direction has rotated normal to the framing. Follow the same procedure to rotate the deck direction in the 2 outer cylindrical regions. One last option is to change the deck overhang. We start by selecting a deck edge and then change its position by using the Edit, Expand, Shrink Areas command. In this case, we set the offset to 12 inches and see that the edge expands out beyond the grid line. However, for this model, we will leave the deck as originally drawn. We can view the initial assigns by going to the Set Building View option and selecting Line Sections. A right-click on a member will bring up specific information, including that this member is to be designed as a composite beam. The program assumes this because the member is horizontal, it is pinned at both ends, and it is either an eye or channel shape. The Assignments tab shows that the member is part of the Auto-Select Composite Beam list. The Auto-Select Composite Beam list is a predefined list of sections. Which range in size from W10 by 12 to W27 by 84. The W14 by 30 initially selected is simply the median size member in this list. All of the design controls are available through the Options, Preferences, Composite Beam Design command. including whether the beam is shored, the factor for pattern loads, deflection limits, vibration controls, and whether or not the beam should be optimized based on price. This is also where specific design codes are selected, and for our example we will use AISC ASD 89. A quick check of the load cases shows that we have two, a dead load with self-weight and a live load. We are now ready to run the analysis. With the analysis complete, start the composite beam design using the Start Design Without Similarity command. Once the design is complete, we can window in to see that the program has selected a W12 by 19 with 8 shear studs as the typical beam. Once again, the composite design parameters are available through the Options, Preferences, Composite Beam Design command. If we go to the Vibration tab, we can ask the program to consider frequency in the design. After we rerun the composite design, note that the typical beams have been increased in size to a W16 by 26 with 8 shear studs to reduce the effects of vibration. This concludes this tutorial.